Hi all, welcome back. Today is Friday, October 2nd. If I didn't say it yesterday, happy new month. And let's get started. We are continuing with matter. Today we're going to learn how to actually separate the different types of matters that we have. So our learning target for today is I can recognize different techniques that separate various forms of matter. So with this lesson, you guys have a reading, and then you have to fill in the graphic organizer. Then I've given you a couple of Regents questions to do, and then your exit slip, right? So easy peasy, lemon squeezy. You do have your do now, which I'm not doing on here with you just because I really want to know how you guys are doing with the particle diagrams, and I feel like it's necessary. So go ahead and try the do now on your own, and then we'll get started for today. So we have distillation. Distillation is a chemical separation, right? So it's used to really separate liquid homogeneous mixtures. So anything we have two clear liquids mixed together, or two blue liquids, or any two liquids that are mixed together and it looks all the same it looks the same throughout, we can go ahead and use distillation to separate them. So the way distillation works is distillation allows requires you to put your two liquid mixtures into a flask and then boil them. Now, while you're boiling them, right, a vapor is going to appear because one of the two liquids boiling point has been reached. Boiling point is obviously the point in which it boils. So when it starts boiling, it's going to turn into a vapor. Now, once it turns into a vapor, remember that's only going to happen to one of the liquids. Once it turns into a vapor, it's going to go through the condensing tube, which is right here. And as the vapor goes through the condensing tube, it's going to drop the temperature and allow the vapor to turn back into liquid particles. And once those liquid particles are formed, they travel down the tube and enter into a flask. Now, that flask will be the purified liquid, right? So, distillation is you are separating two liquid homogeneous mixtures based on boiling point. Gonna go through a rundown of it again. It's the liquids, the two liquid homogeneous mixtures are going to enter the flask. You're going to start boiling them. One of them is going to reach a boiling point in which it then becomes a vapor. Once it becomes a vapor, it's going to go through the condensing tube, recondense itself into particles, into solid particles, which are liquid particles, and then collect itself into a purified version. This is how we get this is how we get vodka. This is how we get vodka. This is how they create vodka. This is how they create a lot of moonshine. Um, this is basically how they get a lot of drinking alcohol that we have of today. Next separation technique is filtration. Filtration you've actually seen a lot in um, in your days. So filtration is a physical separation. It's used to separate homogeneous mixtures made of solids and liquids. So if we have like sand mixed with water or sand, salt, and water, um, or orange juice and pulp, right? So filtration is used for that. And for filtration, you're gonna have a glass funnel, filter paper, and then you're gonna have beaker at the bottom. And what you're going to do is you're going to put the funnel paper, the filter paper, into the funnel, and then you're going to pour your slurry. I'm going to call it a slurry for right now. You're going to put your slurry into the filter paper that's in the funnel. What's going to happen is the liquid is going to filter itself out and the solid is going to remain, right? This was all done by gravitational pull. So there's when you get into a higher caliber of labs, that's when you start using the vacuum to help you create that seal and to allow the filtration system to happen a lot quicker. But at our level, all we use is the gravitational pull. That's going to allow the liquid to pull right through, and the solid is going to remain. Um, we've seen a lot of filtration if you've ever made coffee. That's a filtration system. If you've ever used a sieve, that's a filtration system. So filtration systems are not brand new, but they do, and I want us to focus on this, they do allow us to separate solids and liquids, heterogeneous mixtures. So there must be a solid somewhere. Now, the next one will be evaporation. Evaporation will also be a separation, a separate physical separation. It's used to separate liquid homogeneous mixtures that have had a solid dissolved in it. I know that doesn't say that here, but that has had a solid dissolved in it. So, for example, salt water, right? If we want to get the salt back, what we have to do is place the salt water into a beaker and then put it over a heating flame, a heating device or a flame. And what's going to happen is slowly the water will evaporate and the crystals of whatever was dissolved will start combining, and we will get our salt back. So, evaporation you've seen a lot. We have evaporation happen every day. Evaporation would be an example of, I want to say, like ocean water. That's how we get a lot of our salt. Ocean water, dissolving ocean water to get sea salt. That's an example of evaporation. Um, yeah, right? So remember, it's putting the sample, for the sample to work, you must have had a solid dissolve in a liquid because you want that solid back. And once that solid is in the dish, all you do is apply a flame or a heat source, and that will cause the liquid to evaporate. Now, sometimes you might not need to apply a flame. You could just leave it alone. Leave it alone and let nature take its course, and that means the liquid will slowly evaporate on its own, leaving the solid behind. And our last one is chromatography. Chromatography happens to be one of my favorites. If you've ever watched CSI or NCIS or any criminal lab shows. They use a lot of chromatography. They don't use it the same way as we do. There's a higher level of chromatography that you do at a higher level, but it's similar. Still the same technique. So chromatography is a chemical separation. It's used to separate liquid homogeneous mixtures. It's mostly for dyes, right? So if you find something if you want to separate the chemicals in a dye or ink, you go ahead and use chromatography, right? So what happens is you have a filter paper, you place a dot of your dye or your ink onto the filter paper, and then you put the filter paper in a solvent. Solvent could be alcohol, right? And slowly over time, as the alcohol travels over the filter paper, you're going to see that the ink is going to start running and it's going to start traveling upwards. When we're done with that, all we have to do is separate the distance in centimeters and we're able to identify what the substance is. So chromatography is being able to identify what's in an ink sample, right? And it's usually a liquid homogeneous mixture. It is a chemical separation. All right. So those are our four main separation techniques. We use others. But for right now, you're always going to hear about these four. So let's go ahead and let's see if we can identify which separation technique we can use to help us separate these substances or mixtures. Sand and water. If you're going to separate sand and water, you would use filtration, yes, because sand and water is a heterogeneous mixture, and the sand particles will remain in the filter, and the water would be filtered out. Okay, what about rubbing alcohol and water? Well, rubbing alcohol is clear and water is clear, so they're going to form a homogeneous liquid mixture, meaning for me to dissolve both of them because they're liquid and homogeneous, I'm going to use distillation. And rubbing alcohol has a higher boiling point than, actually a lower boiling point. Yeah, rubbing alcohol has a lower boiling point than water, so it would dissolve. It would boil a whole lot faster. Marker. Well, to go ahead and separate a marker to find out the components that we have in a marker, the only separation technique that we use for ink or dyes would be chromatography. Sugar water. Sugar water. Well, the sugar would have dissolved into the water, so it's not a heterogeneous mixture, it's a homogeneous mixture. That means I would have to use evaporation to get the sugar back. Salt water. Once again, the salt would have dissolved into the water. Thus, I cannot use distillation or filtration, so I must use evaporation. Acetone, which is like nail polish remover, and water. Once again, acetone is clear, water is also clear. So when they mix together, because they're two liquids, I'm going to have to use distillation. Ink, once again, the only technique that separates inks or dyes would be chromatography. Salt and alcohol. Well, let's see. I'm going to leave that to you guys. Try to figure out salt and alcohol. What separation technique will work for that? And we'll discuss it during our live session. Alright, guys, it was good talking to you today. Hopefully, this helped. Do the reading, complete the notes, and I will see you during your live session for any assistance that you need. Have a great day.